defects later, right? What we are seeing is that this specific component went from a very poor PQI, from something that's a little better, but never crossed the threshold, right? The sensor will be here. That means if we're driving a car, right, and if suddenly something happens, we never were able to bring the car back and track in the direction we expect. Right? For any given reason, it's a big component, it's a customer, I mean, nobody cares, but the final point is we were not able to bring the performance to help with the expectations. Could we move to the next one? Now we're going to see the same graphic with defects of user acceptance testing, and let's see how it works, right? Still, we have some components with one defect, right? But the ones with defects in production have the more defects signed in UAT. Still, what we should expect. Go to the next. Well, you see that the movement here makes the predictions in every single phase. So part of the movement is because I realize that I'm doing wrong and I might be doing better. The other thing is you might slack a little bit, right? You say, I got a 9.8 PQI, so that's something that might happen. It's usually not the way it does, but it may. We'll go to the next one. Here, we're going to change here to total defects, just to see how it's like. But it's actually the same thing, right? The bigger ones, the ones that we knew about those components since the very beginning. And if we have implemented something like this, probably the result have been different. Because, I mean, if you look at the data and trail back, everyone should know. Probably nobody realizes. Is that true? Because, I mean, if you get 50 people doing coding, right, and even too many coaches or whatever, you might not realize. The other things, some of these components, especially this one, were split off in different mini components, right, because they were widely underestimated. Could you show here the sizes graph? Just to take a look about actual size. Versus estimated size, right? Well, it should look great, right? But it's pretty much a lot of disturbance here. And that's typical results. I mean, we're not expecting to make them in the results, but they could move in that direction. Questions here? It's an interesting analysis because go to the next one. This graph is really interesting, right? What it's saying is that as we move forward with the process development cycle, our estimation gets much better, of the PQI gets much better. But still, we are not trying to get this line, right? We're not trying to predict PQI. What we are really trying to do is to prevent from defects to get from the customer. It's not about having the perfect formula for PQI development. We're trying to prevent challenger exposure, right? We are bringing the time machine back and say, well, if you get an opportunity again to make this component, what would you do different, right? And that's the main challenge. How do we make those technologies back to the developers to make them have or make better decisions, right? And it gets more interesting. The problem with this is that you could play with this all the day, and you could see pretty interesting tiers. What we do here is we take out all the other components, all the noise, right? Only interesting in those that have production defects. We could see, as I said before, that we never cross that threshold, right? And then we're going to change the scale a little bit in order to sum in, because we got clearer things here, right? Logarithmic. And then, just like magic, right? As you can see, this one